मैं आपको सिंपली बता रहा था कि a reaction that proceeds in one direction is called an irreversible reaction. For example, these are a few examples of irreversible reactions, right? This reaction is also called precipitation because there's a precipitate being formed in the form of AgCl, right? This is also called a neutralization reaction because a salt is formed, or you could say an acid and a base neutralize, right? Acid base reaction, again, this is called a neutralization reaction. All of these are irreversible reactions. One feature that you must have noticed is that there is only the arrow in one direction. When reaction proceeds in both forward and backward reaction, it is called a reversible reaction. There are two half arrows, right? Calcium carbonate, when heated, produces calcium oxide plus carbon dioxide. This calcium oxide can further react with carbon dioxide, which is an acidic oxide, to form calcium carbonate, right? Please understand that forward reaction is decomposition, right? Whereas the backward reaction is an acid-base reaction. Moving forward, hydrogen when reacted with iodine gives you 2Hi, again reversible reaction. Ethanoic acid with alcohol gives you ester. All of this is done in O levels. It's just a revision of that. Dynamic equilibrium. Let's say you have the reaction A, B, C, D. A and B are your reactants, C and D are your products. M, N, X, and Y are the number of moles, right? If you were to calculate the rate of the reaction, rate of the forward reaction, you could say, you would increase the concentration of the reactants so that they convert and move into the product side, right? So rate of the reaction is directly proportional to the concentration of the reactants. And the rate of the backward reaction would simply be proportional to the concentration of the products, such that, right? So you need to understand that initially when time is 0, concentration of the reactants is high, right? While the products is 0, or you could say low. So rate of the forward reaction is high, you could say, because your reactants are have just started to convert into products. After a short time, your reactants would start to decrease, whereas your number of products would start to increase, right? So in that case, you could say C and D are increasing, right? Or you could alternatively say, okay. There comes a point, let's say, when your reactants are converting into products and products are converting into reactants. Don't you think there will come a point when your rate of forward reaction is equal to the rate of the backward reaction?
So
right?
Please
understand, please. Exactly. Please understand that the point where the rate of the forward reaction is equal to the rate of the backward reaction is a situation called the dynamic equilibrium, and it will always be achieved in a closed vessel. Right? Moving forward, there are types of equilibrium. There's homogeneous equilibrium, where the reactants and products will exist in the same physical state. See, your reactants are gaseous, your products are also gaseous, right? Heterogeneous equilibria is where reactants and products exist in different physical states. See, right? Concentration time graph, your concentration of the reactants is decreasing, whereas the concentration of the products increase. However, for a reversible reaction, the concentration of reactants decrease, but do not decrease fully. However, the concentration of the products increase, but do not increase fully. So at the point where the rate of the forward is equal to rate of backward, this point is called the dynamic equilibrium. I simply stated that there are two types of reaction. One is a reversible, one is an irreversible reaction. For an irreversible reaction, all of the reactants will convert into the products, right? So see, the reactants are decreasing until the point 0, whereas products are simultaneously increasing to its maximum value. While for a reversible reaction, not all of it is consumed, so they become equal. The rate of the forward and backward become equal to a certain point, after a certain point. If you were to draw a rate, moving forward, rate versus time graph, again, rate of the forward reaction C is decreasing, rate of the backward reaction is increasing. Please understand that on time graph is correct. This concentration time graph is again correct. However, this is not a dynamic equilibrium. This is not a dynamic equilibrium. The reactions should have the rates equal and right. It's a very different graph.
So आवाज कट रही है.
Can revolve. The rate equation cannot revolve around like this. The rate equation cannot.
सर आवाज नहीं आई थी आपकी पहले.
मैं कह रहा हूँ यार, ऊपर के दो ग्राफ्स देख लो. Check out this and check out this. The rate equation cannot revolve around this. The rate equation cannot be drawn like this. The graph cannot be drawn like this. These are some correct formats of the graph.